Let's do another equation then. Okay, finish the equation. Finish the equation. Oop, I need to put a 2 here. Scroll back up. To right there? Yes. That's a 2. Yes, sir.
If you still living and I run for president, will you vote for me?
Well, it depends. What party are you going to run for?
I don't know.
Say Republican.
Going to be a Republican or a Democrat?
Both.
Or an independent?
The Green Peace Party.
The what?
Okay, I'll be a Republican.
No.
Wow. And why are you going to run as a Republican?
Why?
Yeah. Huh? Just seems cool? No, if the only reason you're a Republican is because it seems cool, I'm not voting for you in any case. Well, a lot of it depends on do you actually embrace the values of the Republican Party or embrace the values of the Democratic Party, and how far you go on that, because there's a whole range of values within the Republican and Democratic Party. So I vote for people based on issues. Okay? So if a candidate, in my opinion, is doing things that aren't good for public education, I probably won't vote for him. All right, everybody got this done? Well, not when you count them. When you count them, you don't have to list it last. You just have to balance it last.
How come it is like react? Because S is below CR2.
That's correct. So the element that's by itself is higher on the activity series than the element in the compound. Okay? The element that's by itself is higher on the activity series than the element it is like in the compound. Okay? Got that? All right, yes.
Why do you have to do opposite?
Having balanced hundreds and hundreds of equations myself, it is my personal experience that you are more likely to be successful balancing equations if you save oxygen for last. Okay? Yes?
I'm just going to put 2 after the CL3 for the chromium.
Okay. Well, this is going back 2 units. Let's take a look. So if chromium, if 10 SN will replace, chromium will replace 10, and chromium will replace 10. Okay, it's higher on the activity series. Then I need to know what form of chromium I'm going to get. Well, right here it tells you the most likely form is going to be chromium 2 plus. So chromium 2 plus. And then I can go over here and find this polyatomic ion on the common ions list. And let's see, there's ClO3 right there. It's chlorate, has a 1 negative charge. Okay? Say what? Okay? So if I have a 2 plus here and a 1 negative here, and the whole thing needs to come out to be 0 when I'm done, what do I multiply these two by? What coefficients do I put in front of them? 1 and a 2. That means I need 2 of these. Therefore, I need 2 chlorates. Does that make sense? Okay? Yes, sir.
It says that chromium's oxidation numbers are 6 positive, 2 positive on the periodic table of oxidation numbers. Why is that different?
Why is it different?
On the scale.
I mean, on the activity series? Because in a single replacement reaction, this is the most likely product you're going to get. Okay? Yeah, you could get a 6 plus, but it's unlikely.
So when we're like balancing the equation, like do we look at the activity series for the charge?
If it's a single replacement reaction, you do. Okay? For a single replacement reaction, that's what you look for. All right? Any other questions about that? All right, then, let's do this. Okay, now let's do this individually and do it quietly. Okay, work this one out. How long do you think I should let this go on, Jay Breezy? Is it long enough yet? What about it, Connor? Goose? Should I let it keep going on? Should I put these other people up through all this torture? Okay, if you don't understand that, find a neighbor who does and have them explain it to you. I let it go on for a while for this purpose. The people who got it, great. The people who didn't get it when I said that the element by itself has to be higher, sometimes it takes a while for it to sink in. So one of the best ways is to, let them go through it and realize, wait a minute, I have to do all that, It's a good way to learn. Okay, so I'm not trying to punish anybody, but I am trying to get it, doing well. So, okay. All right, let's do this one, please. Last one. Work this out, please. Yes, dear. We will get to that. We'll get to that. If you don't know yet, don't worry about it. I was kind of saving the aqueous and solid part till we get to the double replacement reactions, okay? Metals that are by themselves, except for mercury, you always assume to be solids, okay? Yes. Okay. Yes.
Put parentheses around the chlorine.
No. You use the parentheses when you have a polyatomic ion that you need to show there's more than one of.
I thought the zinc would replace the chlorine.
No, zinc's not like chlorine. Zinc's a metal and chlorine's a non-metal. Chlorine is a halogen, but zinc isn't a halogen. So halogens can replace halogens, but metals don't replace halogens. But metals can replace other metals or hydrogen. Okay? And when zinc replaces hydrogen, the result is H2, or hydrogen gas. Yes?
You know how I have a little box with the activity of halogens?
Yeah.
Can any of those replace any of those? Or is that
Yeah.
like above?
Well, anything above it replaces anything below it, just like on the metals. Yeah, works the same.
What if you
Okay?
had,
I'm listening.
Actually, I don't think that would work for the
Yes, dear.
so yeah, if it was like chlorine because it's charged in negative, it's charged with 1 negative, and then zinc charged with 2 plus.
You got it.
Okay.
You got it. The zinc is a 2+ charge, and you find that on the periodic table with oxidation numbers. And chlorine, while chlorine has multiple oxidation numbers, the only oxidation number that will give you a neutral charge is the negative, and chlorine only has one kind of negative charge, a 1 negative. Okay? So you see how all this stuff we learned 2 units ago is going to be really important in this unit? Because you've got to balance those formulas. All right, now, here's something you need to know. Here's something you need to know. Whenever a metal reacts with an acid, remember this is an acid because it has hydrogen on the front of the formula. Whenever a metal reacts with a pure metal, okay, not a metal in a compound necessarily, but when metal reacts with an acid, any kind of acid, you always are going to produce hydrogen gas. Anytime a metal reacts with an acid, not all metals will, but when a metal reacts with an acid, you're always going to produce hydrogen gas. Now, let's also take a look over here at the activity series because there's a whole bunch of extra stuff written down here. See all that stuff down there? Okay, this becomes important with physical states. Okay? All right. So, all these metals down through mercury here, all these metals will react with oxygen to form oxides. Okay? So that's not really part of our activity series, but you need to know that if I have lead and oxygen, it's going to form lead oxide. Okay? That's part of the activity series. Okay? It's not a typical part, but it's there. Alright? It's not one we typically use, but it's there. Now this says all of these elements down through lead will react with acids to form hydrogen gas. Well, I just said that, didn't I? If it reacts with hydrogen, it forms hydrogen gas. Okay? All the elements down through cadmium will react with steam to form hydrogen gas. Well, that makes water an acid if it's in the form of steam. Okay, so all these metals will react with water like water is an acid as long as it's steam. Okay? These top 6 elements here, lithium through sodium, will react with water itself, even cold water, to form hydrogen gas.